This is a technical briefing on the n8n Guardrails node. The node is a component designed for policy enforcement in AI workflows.
The briefing is structured in 6 sections. The initial sections cover core function, architecture, and the node's operational modes. Subsequent sections detail the pattern-based and LLM-based guardrail capabilities. The final sections address operational integration, performance characteristics, and scaling limitations.
The first section details the node's fundamental purpose and its position within the n8n workflow ecosystem. Introduced in NN version 1.119, the Guardrails node functions as a policy enforcement component within a workflow. Its primary role is to filter text data for the inputs and outputs of AI agents.
The node's behavior within a workflow is determined by one of 2 distinct operational modes.
The Check Text for Violations mode analyzes input and outputs a Boolean passed status along with violation details. This output facilitates conditional branching in the workflow. The Sanitize Text mode analyzes input, redacts content that violates policy with placeholders, and allows the workflow to continue with the sanitized data.
A set of guardrails functions through deterministic pattern matching. These operations are performed locally and do not require external API calls to a large language model.
There are 5 pattern-based guardrails. The keywords guardrail operates only in check mode to block specified words or phrases. The other 4 guardrails, PII, secret keys, URL management, and custom regex, support both check and sanitize modes. They are used to detect or remove personally identifiable information, credentials, control URL access, and apply custom validation rules via regular expressions. In Sanitize mode, the PII guardrail identifies multiple entity types, such as names, dates of birth, and credit card numbers, and replaces them with a redacted placeholder. The Secret Keys guardrail detects patterns associated with common credential formats, including API keys, AWS keys, and JWTs. In check mode, it flags a violation. In Sanitize mode, it redacts the detected credentials.
A second category of guardrails relies on an external chat model for analysis. Their operation requires an API call to the configured model.
This category comprises 4 guardrails, each necessitating an API call to a configured LLM. The jailbreak detection guardrail is designed to identify prompt injection attempts. NSF detection flags explicit content. Topical alignment ensures text conforms to a defined conversational scope. The custom LLM guardrail allows for user-defined rules articulated via a prompt.
The jailbreak detection guardrail sends input text to an LLM to analyze for common exploit patterns. The LLM's assessment is then compared against a user-configurable threshold to determine if a violation has occurred.
The topical alignment guardrail uses an LLM to evaluate if a given text input is relevant to a predefined list of allowed topics. Inputs that deviate from the specified topics are flagged as violations. This section covers the operational prerequisites and configurable parameters for the node.
Operation of the node has 2 main prerequisites. First, the n8n instance must be version 1.119 or newer. Second, the use of any LLM-based guardrail necessitates a configured chat model credential.
LLM-based guardrails feature a configurable numeric threshold. This parameter adjusts the sensitivity of the detection mechanism. Altering the threshold affects the balance between the rate of true positive detections and the rate of false positives. The node has specific performance characteristics that define its intended use cases and operational constraints.
A primary operational constraint of the Guardrails node is that it is not designed for large-scale data validation or bulk cleaning operations. Pattern-based checks introduce a processing latency of 50 to 500 milliseconds per item. LLM-based checks, which involve external API calls, add 1 to 5 seconds of latency per item. Consequently, neither type is suitable for bulk processing.
The node is designed for real-time, low-volume applications. Suitable use cases include real-time user input validation, individual API request validation, per-message content moderation in conversational flows, and processing of single items in low-frequency workflows.
The node is not suitable for high-throughput scenarios. Unsuitable use cases include the bulk processing of hundreds or thousands of records, batch cleaning of large data sets, high-frequency triggers with multiple items per execution, and data migration tasks.
The use of LLM-based guardrails has direct cost implications related to API usage. Based on pricing for GPT 3.5, the estimated cost to process 1 million items with a single LLM-based guardrail is approximately $1,500.
The design of the Guardrails node prioritizes granular, real-time control for individual items. This design choice results in lower processing throughput and, for LLM-based guardrails, direct API-related expenditure.